Hello students, today we are going to start the reaction of metal with non-metal. Reaction of metal with non-metals. As we discussed, the metal means the element which has some crystalline property, okay, ductile property, malleable property, sonorous property, but but the non-metal does not have this property. These are the physical property that we are showing or we are feeling from outside. But internally, what is the property of metal and non-metal? Here internally means how the electrons are oriented in the metal and non-metals. Okay, let's see. Suppose we are taking an example. We are taking an example of sodium. Sodium has atomic number is 11. Now what its electronic configurations? If we write electronic configuration, it would be 2.8. That means in first shell, that means K shell, it is 2 electron, L shell 8 electron, in M shell it is only 1 electron. Okay, now let us draw the orbit. This is the nucleus of sodium. This is the K shell, and here is only 2 electron. This one is the second shell, that means L shell, and here is 8 electron, and this one is the third shell, that means M shell, and here is only 1 electron. Here is E minus, means since electron is negatively charged, that's why I am written E minus. E minus nothing but the electron. Now see, these two are inner shell. Inner shell. Okay, inner shell means it is inside. Okay, now this one is outer shell. Outer shell. Outer shell has some other name also. It is known as valence shell. Valence shell. Now valence shell means the outermost shell, as I am said. Now the electron in the valence shell or outermost shell is known as the valence electron. Okay. This valence electron is only responsible for the formation of bond for any species with the other species. Okay. Now see what happened with metal and non-metal now. Now see, metal, as I know, metal are reactive. Now reactive means they wants to react with the other species. Okay. Why they wants to react? Because see, here is the valence shell, only 1 electron is there. This 1 electron is alone. So this 1 electron is not stable. It is not stable. That's why this 1 electron wants to transfer, or you can say this 1 electron is want to give to another element to form a bond. That's why metals are more reactive than the non-metal. Okay. Now what happened with the non-metal? Now let's see an example. Suppose here is a chlorine is a non-metal. Okay. Its electronic number is how much? Electronic number is 17. So if you want to write its electronic configuration, then it would be 287. That means according to octet rule, it has only 1 electron. It needs 1 electron to become a stable configuration. It needs only 1 electron to become a stable configuration according to octet rule. Octet means 8. Okay. So now see, this species, that means chlorine, wants to take electron, but this one is wants to give electron. The species which gives electron is known as metal, and the species which gain electron or which wants to take electron, it's normally named as non-metal. But it's not for all cases, remember. But for metal there is always tendency to give electron to the other species, and these are metal. Okay. Now see what happens if metal gives an electron and non-metal takes electron. Now let's see. See, here is sodium and here is a chlorine. Okay. Now see, sodium has one electron in its valence shell. Okay. As I said, only valence electron will participate in the bond formation. That's why suppose here is a 1 electron. But in chlorine there is 7 electron in its valence shell. 1, 2, 3, 4, 5, 6, 7. 7 dot means 7 electron. Now see, since it is a metal, it has a tendency to donate the electron to the other species. Now if it donates, that means it becomes positive. Okay. Now it takes the electron, no, then it becomes negative. Donation of electron makes it positive, and accepting of electron it becomes negative. Now the attraction between this positive and negative charge makes it closer. And one type of electrostatic, that means plus minus attraction bond is formed, and this type of bond forming compounds are known as ionic compound or electrovalent compound. Ionic compound or electrovalent compound. Now what do you mean the ionic? Ionic means here is forms, no, positive ion and negative ion, that's why it's ionic compound. And electrovalent means this electrons transferring takes place from one element to another, that's why it is electrovalent compound also. Okay. Now see the other example. We are taking another example. Okay. See, suppose we are taking not potassium similar type of sodium. Okay. Now let us take magnesium. Magnesium is another metal and its electronic number is 12 and its electronic configuration is 282. That means 2 electron in the valence shell, no, valence shell. Suppose here is another atom. Suppose it is what? Suppose we are taking chlorine also. Only chlorine has the same 1, 2, 3, 4, 5, 6, 7 electron, but it has 2 electron in its valence shell. Now see what happens. If this 1 electron gives to chlorine, okay, then it becomes -1 and it becomes +1. Okay, it becomes +1. Since 1 electron is given to chlorine, then it becomes 8 electron, no? So according to octet it's stable, but the remaining 1 electron, the magnesium metal wants to give with another chlorine atom. Suppose we are taking here is another chlorine atom. Here also same electronic configuration 1, 2, 3, 4, 5, 6, 7. This another electron wants to give to another chlorine atom, which makes it another negative. That's why now it becomes 2 positive, because it gives 2 electron to different chlorine atom. Okay. Now see, this 2 positive and here is 1 negative and 1 negative, that means neutral. 2 positive, 2 negative, and this attraction between 2 positive and 2 negatives makes it ionic compound. That means Mg Cl2. Okay, let us take another example. Okay, let us take another example. Ionic compounds are not molecule, but they are aggregate. Aggregate is a new term. Aggregate. Aggregate means 2, 3, 5 or 50, 60 molecule of that particular ionic compound comes close together and form a crystal, and these are aggregate. Okay, suppose we are taking, these are the sodium chloride molecule. Suppose here is some sodium chloride molecule. No, these are one aggregate. Aggregate. Here also some molecules and forms aggregate. Here also some molecules forms aggregate, and these are the aggregate and known as crystal. Okay, crystal. Okay, next is the definition of, suppose, ionic compound. Ionic compound ionic compounds are the compounds formed by the transfer, okay, by the transfer of electrons from metal to non metal. Okay, and it's occupy charge, and it has charge. That means, suppose we are taking any ionic compound. Suppose this well-known compound is, suppose, KCl. KCl is potassium chloride. Okay, similar type of compound of NaCl. Here also this one is plus, this one is minus. No, this one is metal, but this one is non-metal. This one is metal, this one is non-metal. Non-metal transfers, that means leave electron to the non-metal. That's why it becomes positive and then it becomes negative. And the attraction between these positive negatives makes it closer and forms an ionic compound. Okay. Remember this one. This ionic bond, or you can say ionic attraction, is the strongest attraction in the molecule. Okay. Now see what are the properties of ionic compounds. Okay. See. Properties of ionic compound. First property is the physical state. Physical state means the compounds are in which states? Gas, liquid or solid. Okay. Ionic compound are in solid state. Why solid states? Because of the strong intermolecular force of attraction between them. Because of molecular force of attraction between them. This them means particles. Okay, you can write particles. Now see how. Suppose we are taking example of sodium chloride. Due to this positive charge and negative charge, okay, there is a strong force of attraction between the sodium and chlorine. That's why these are solid. These are solid. Okay. Now if you want to break this one, if you want to break sodium chloride, then we need to apply a very high amount of force to this, because it is strongly binded together. Okay. Now see the next properties. Next properties is the melting or boiling point, you can say. Next properties is melting point or boiling point. Melting point and boiling point. Now first of all we have to know what we mean by melting and boiling point. See. Melting point means it's the temperature. Melting point means is the temperature at which the particular compound is melted. Okay, this one boiling point. Boiling point is the temperature at which the compound is boiled. Compound is boiled. Suppose we are taking example of one salt, magnesium sulfate. This one is an ionic compound. This one is an ionic compound. Here, if you observe, here is a strong intermolecular force of attraction, because here is positive, here is negative. Due to this strong force between this magnesium and sulfate ion, the molecule needs so much high temperature to melt. The molecule needs so much high temperature to melt. Suppose you can do one experiment in your home also. Okay, I am explaining. Suppose this is a burner. This is a gas burner. Okay. Now here we are taking a simple container, metal container. Okay, and taking 1 spoon of suppose salt. Our normal salt. 1 spoon of suppose normal salt. When we heat, we can observe the sodium chloride does not melt easily. Okay, it needs more than 100 Kelvin. More than 100 Kelvin need for the melting of sodium chloride. That means it is very strong, or you can say it has very high melting point temperature. Okay, that's why I'm saying, because of their strong intermolecular force of attraction. Okay, see the next property. And similar case in boiling point also. Okay, similar case in boiling point also. Next property. Next property is the solubility. Okay, solubility. Next property is the solubility. Solubility means the compound is soluble in a solvent or not. Suppose we are taking an example of sodium chloride. When we give water to sodium chloride, obviously it will dissolve. It will dissolve. Okay. Now what happens if it dissolve? Now see. When we test this one, this one obviously solid test. In similar case, when we test the dissolved solution of sodium chloride, it also tests same as that of salt. Same as that of salt, because you can say from this experiment here also some salt, no, but it is in dissolved state. Now this dissolved state not dissolved we know, but how can we say chemically what is going on in the dissolved state? Chemically, when sodium chloride or any salt, okay, any salt dissolved in water, it dissociated. That means it breaks down into their ions. Suppose here is it dissolves in sodium positive and Cl negative. It breaks down into sodium positive and Cl negative. That means a particular salt, when it react or dissolve in water, it dissociate into their corresponding ions. Okay, and these ions are stabilized by water. Okay, these ions are stabilized by water. That's why we need water to dissolve. Okay, this one needed. Understood? No? See the next. Next property is the flame color. Flame color. Now what do you mean by flame color? Okay. Flame color. Suppose there is a burner. There is a burner. Okay. Here is a burner. We are taking a glass rod. This one is a glass rod. This one is a glass rod. And in this glass rod, in this portion, we are taking small amount of any salt. Small amount of any salt. When this salt is heated, it will burn and produce a different type of color. It will produce different type of color. Okay, depending on this color, we can say the nature of the salt, or we can detect the component of the salt. Okay, component of the salt. Then let us take an example. Okay, now see an example. Here it is salt, no? Now we are giving here sodium chloride salt. Now when the sodium chloride burned in this flame, it will produce yellow colored flame. Yellow colored flame. From this yellow color flame, we can say our salt contain sodium. That is the metal. Okay, that is the metal. Next property. See the next property. Next property is the conductivity or next property is the next property is the conductivity of electricity. Okay, conductivity of electricity. That means we can say our salt conduct electricity. Now to explain this one, suppose let us take an example of an experiment. Suppose here is a beaker. Okay, it's a beaker. In this beaker we are added a metal rod. This one is a metal rod. This one is another metal rod. These two are metal rod. This may be any metal. Suppose we are taking example of copper. This one also copper rod. Okay, Cu means copper. Copper. Now this rod are connected to a battery. This is a battery, and then with a little bulb. Suppose this one is a bulb, and is connected again to the electrode. Suppose this one is taken as a positive and this one is taken as a negative electrode. There is a battery, no? There should be positive and negative. That's why here is positive and negative. Now see, if we connect this battery, the bulb will bright or not? Obviously not. Why? Because here there is no connection between these two electrodes. That means the circuit is not complete, no? Circuit is not complete. Now we are added water, that means distilled water. Here is, now it is distilled water. Distilled water. When it is distilled water, then also there will be no flow or transfer of electricity, because only water, that means distilled water, cannot conduct electricity. But when we add, suppose 2 spoon of, suppose 5 gram of any salt, suppose sodium chloride, our normal salt, sodium chloride, 5 gram of sodium chloride we are added. Now when this sodium chloride is added to water, obviously it will dissociate, no? That means it produces lots of sodium positive and lots of chlorine negative. This sodium positive and chlorine negative, having the positive and negative charge respectively, moves throughout the solution. That means move randomly throughout the solutions. Now if this moves, then obviously it can carry the electron, no? It can carry the electron because these are ions. If it can carry electron, then obviously the electron from here to here can be transferred. Here to here can be transferred with the help of these ions. If electrons transfer or electrons flows from one position to another, this is the name of electricity. That's why when salt is added to water, then the bulb will bright. That means this salt produce or transferred electricity, and this property is known as the conductivity of electricity. Okay, that means it conduct, no, from one position to another positions. That's why the solution of salt, that means solution, not the solid salt. Okay, solution of salt, any salt, conduct electricity because it can randomly move throughout the solutions. But if you take an example of, suppose I'm taking an example. So this one star mark I'm writing. Structure of solid salt. Okay, the solid salt will not conduct electricity because solid salt means what? It's compact, no? It's compact structure, and it cannot move in the solid and does not conduct electricity. Okay, but in molten state, second condition is molten state. Molten state of salt. But molten state, that means the melted. Molten state of salt can conduct electricity because due to the molten state, it can move from one position to another position and carry electron from one into another. That's why the molten state and the solution of salt can carry or conduct electricity. Okay? Thank you.